Assalamualaikum warahmatullahi wabarakatuh. Hello, ladies and gentlemen. Greeting from Indonesia. How are you? Thank you everyone for coming to my presentation. Let me introduce myself. My name is Afrita Amelia. I am the first author of this paper. And today, I would like to tell you about review on target tracking method in multimedia wireless sensor networks. This research is based on our collaborative research between Politeknik Negeri Medan and Universitas Sumatera Utara in Indonesia. And this is what our research has been looking at. So, let's get started. There are 4 things that will be discussed in this paper, namely introduction, multimedia wireless sensor network, related works, and the last is conclusion. Multimedia wireless sensor network allows surveillance or monitoring applications using video to be conducted centrally. One of them, target search and tracking, is popular research in the MWSN network. For the purpose of tracking targets, a target recognition algorithm is needed as well as target search algorithm on the network. To be able to track objects efficiently, each node must be able to detect the target according to the direction of the target's movement. A communication protocol that is efficient in coordinating direction tracking will optimize the search. Furthermore, the sensor can perform a search process in the predicted slot, thereby reducing overhead, considering that the main limitations of wireless sensors are energy sources and transmission bandwidth. Which is WSN architecture. The WSN architecture generally consists of many distributed sensor nodes. All data is routed to a base station to be sent to users via the internet network as shown in figure 1. Sensor nodes can coordinate directly with sync nodes if transmission distance allows, as well as route through other sensor nodes if direct transmission is not possible. Let's going on to the next page. Main concern of the MWSN is reducing huge data size and energy consumption during transmission. This method is promising solution to improve network lifetime. In its development, WSN can be collaboration with Internet of Things network, also developing for other applications such as surveillance using cameras using the multimedia wireless sensor network. This method is promising a solution to improve network lifetime. To enable MWSN, a sensor node should have the ability to record objects with good video precision, efficient object detection capabilities, as well as optimal communication protocols and sufficient transmission links to transmit video. Let's move on to the next slide, which is related works. There are several challenges faced in the MWSN network, including high energy consumption and high bandwidth requirements. In fact, one of the popular applications to be researched is a target search and tracking application. To realize the target tracking application, MWSN can use mobile sensor node, static sensor node, or hybrid sensor node, which is a combination of the two types of sensor. To avoid the need for large costs, the SSN application is optimized by optimizing the sensor position to obtain better technical results. Some examples of sensor placement techniques that have been proposed include considering origin, destination, and travel time. OD is one of the sensor placement algorithms which fills in as a significant contribution for traffic determination in order to predict network traffic stream designs. Meanwhile, travel time is one of the sensor placement algorithms taking into account the probability of sensor failure, which is common and inevitable. In addition, there are studies related to target tracking using non-biological techniques such as directional method and receive signal strength. Biological technique is best approach to solve complex problems and nonlinear problems such as neural network, ant colony, and particle swarm optimization. In MSN research, every sensor node is modeled by surveillance capabilities such as ability to record traffic flow, ability to identify police numbers or license plates, and also communication. Multimedia processing at nodes and on servers, it can use trajectory prediction video and audio as well. Meanwhile, the traffic flow is often modeled by using vehicle routing problem and its derivatives. Figure 2 shows a concept of support vector machine. Sensor nodes can observe the movement of objects by measuring the strength of the received signal, which is emitted by moving objects in radio signal. For every perception, every sensor sends one bit of data to central node via WSN. This information from various sensor nodes gives significant information to help SVM and particle filter in tracking moving target efficiently and precisely. Despite sensor perception mistake, MOT SVM can track with satisfactory exactness adaptation to fault tolerance abilities of SVM. From the experimental outcomes, it can be decided that MOT SVM beats the ASLAM calculation. Figure 3 shows architecture of TDNN with delay of 2 at input layer. TDNN is one of example of biological technique which is prediction algorithm based on artificial conditional network with time delay. Aviation tracking can only be achieved if the state of the transition matrix used in the filter is very similar to the movement of the target. Its advantage is that it gives better results than the Kalman filter and the IMM filter in provision of mean square error, which is an approach that measures the mean of the square contrast between the assessed estimate and the genuine worth. However, prediction errors occur and the prediction algorithm performance decreases if the transition matrix state selection does not match the target movement. Okay, let's go to the next topic. Well, everyone, the main point of our material today are: firstly, MWSN is a multimedia wireless sensor network consisting of sensor nodes installed with cameras, where these nodes are connected to every node using wireless connection. Secondly, OD and travel time parameters can be used to avoid the need for large costs by optimizing the sensor position to get better technical results. Thirdly, non-biological techniques such as directional methods and RSS have the following advantages and disadvantages. For instance, directional methods. In scenario 1, the test is called successful if the target is tracked, otherwise it is called unsuccessful. Scenario 2, spread the crossword clues in the corridor of the department. However, the scenario has some implementation constraints. Therefore, it is necessary to rearrange the nodes in a possible location to reduce target tracking errors. And scenario 3, target tracking system or TTS is used on the road to count vehicles. However, lighting problems at night reduce detection accuracy. Furthermore, RSS method, from the experimental results, it can be concluded that MOT SPM outperforms the ASLAM algorithms. However, there may be errors in sensor observations and have not been tested for real environmental scenarios, such as tracking of vehicle on the road, where the trajectory of the object will be very different. Finally, biological techniques such as TDNN give better results than the Kalman filter and the IMM filters in terms of MSE. However, prediction errors occur and prediction algorithm performance decreases if the transition matrix state selection does not match the target movement. The following are references of this paper. Okay, ladies and gentlemen, this is the end of my presentation. That's all that I can say. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.